Hi everyone, welcome to the Chem Help ASAP live stream. Glad you could join us today. I feel like because we're kind of beginning of August, we're in this weird time between summer classes probably finishing up and fall classes not having started yet. So let me know if I'm wrong about this, but I feel like one of the things that we have an opportunity to do here is to take the live streams and maybe prep you for what you're going to see at the beginning of your chemistry classes when you start in the fall. So on that note, we are actually going to be talking about physical and chemical changes tonight, because that is usually one of the early topics that you cover when you start your chemistry class. As always, if you have any questions or comments, please feel free to join us in the chat. We also want to know, especially me with these live streams, how we can best serve you. So again, if you have questions or you want to see a topic covered on the live stream, or even if you have a specific problem that you're struggling with, please let me know. We are definitely here to help you. Okay, with that being said, let's jump right into physical and chemical changes. Okay, so really, before we talk about physical and chemical changes, we have to first define what a chemical and physical property are, physical and chemical properties are, because they are going to tie into the changes, obviously. So what I've done here is I have just defined physical and chemical properties. So let's talk about these just a little bit. So a physical property is one that you see, but the substance does not change composition. Okay, the key word being not here. So any substance, so this can be a pure element like, say, a hunk of iron. This could be a compound like water or ethanol or anything like that. It can be a solid, liquid, or gas, but a physical property might change the appearance of the substance, but it does not actually change its composition. So if you think about like an ice cube melting, it changes the appearance, but it doesn't change the composition. Now, I was thinking about, okay, so what are some common physical properties that substances have? And you have things like color, smell or odor, even taste. Of course, only taste your food items. Do not go into the lab and taste things. Things like melting points and boiling points, freezing points and vaporization points, sublimation points, all of those kind of things. Density, even properties like malleability or ductility, hardness is a physical property. So these are all properties that don't depend on the substance changing composition. Again, the appearance may change, but the substance itself does not change. All right, so now we have a chemical property. Obviously, this is different. And a chemical property is observed when a substance does change. So it's going to change its composition. So things that are chemical properties are things like flammability, toxicity, how much something acts as an acid or a base. Generally, we're talking about reactivity, and that can encompass a lot of different things. It can encompass things like how corrosive something is, or if it's a good oxidizer. All of those kind of properties are chemical properties. And what they are going to do is they are going to take the substance and they are going to change its composition. So if you think about burning a log, one of the chemical properties of wood is that it is flammable. And so to see that property, obviously you're going to change that piece of wood from wood into basically gases and ash. Okay, so those are our two definitions of physical and chemical properties. Now let's work with a couple of problems with this. So these are pretty easy. I'm not actually going to write a whole lot down. There's no math this week, so, enjoy that. So here is just kind of a list of different processes, and we want to think about, do these processes describe a physical property or do they describe a chemical property? All right, so we're just going to go through these. So A is the tendency of copper to turn green when exposed to air. So you see this on like buildings that have copper roofs. They start out really shiny and pretty, and then they turn green. So that is a chemical property of copper because it is actually oxidizing. So it is changing from pure copper to a copper oxide. So that is a chemical property. Okay, so B. Oops, okay, there we go. Now my pen is writing. Okay, so B is the tendency of car paint to dull over time. So you've probably seen this with older cars, especially that sit out in the sun. So especially if you live in a place where the sun is very intense, you probably see this pretty often. And so again, when you have a new car, the paint is very shiny. And then after years and all of this sun exposure, the paint gets dull and gets kind of patchy. So again, is this a physical or chemical property? Is the paint's definitely changing appearance, but is it changing in its chemical composition? And what is actually happening there is the sunlight is changing the chemical composition of the paint, which is why it does not look as good. So car paint dulling over time, that is a chemical property. All right, so C. So we've got how rubbing alcohol evaporates quickly. So you've probably most notice this, or I remember noticing this mostly in the doctor's office. Before you get a shot, you get the alcohol patch like on your arm, and it feels cool because the alcohol is evaporating. So again, is this a physical property or a chemical property? Is the substance changing? So rubbing alcohol in that situation, it's on your skin as a liquid, but then it evaporates and it becomes a gas. However, the chemical bonding in that rubbing alcohol does not change. So evaporation, generally all your phase changes are going to be physical properties because you're not changing the substance itself. Okay, let's keep on going. So we have D is a toy made from iron is much heavier than the same toy made from aluminum. Okay, so what we have really is, if you think about the same toy, but one is made from iron and one is made from aluminum, you do have a weight difference, but what that really specifies is a difference in density between the two metals. So if you've made the same toy, theoretically you would use the same volume of metal, but obviously the mass is different. So that is a difference in density. Density is a physical property. So this part D is definitely going to be a physical property of the metal. It does not change. Okay, keep on going. We're almost there. We're over halfway. Okay, so E is an explosion of hydrogen gas. Of course, this is most famous in the Hindenburg explosion. And what we've done is you've taken hydrogen, it has reacted with the oxygen in the air, and it's actually produced water vapor. So this will be a chemical property because we no longer have hydrogen gas, H2. We have changed its bonding. Okay, so E is a chemical property. F, the color of gold versus silver. So, of course, gold is a different color than silver. Most metals actually look more like silver. So is color going to be a physical or a chemical property? Well, the color is just based on usually the atomic structure, especially with gold. That's why it's that color. This is not going to change the substance or have anything to do with chemical bonding. So color is going to be a physical property. Okay, G is the process of dry ice changing from solid to vapor. So you might have done this if you had a shipment of something that was really cold. I remember as a kid, this was always super fun to do. You get a chunk of dry ice, you pour a little water on top, and you get lots of water vapor coming off. So what we've got here is we've got a phase change. We're going from solid to vapor because, of course, dry ice does not actually pass through the liquid phase at atmospheric pressure at that point. So a phase change does not change what dry ice is, which is, of course, carbon dioxide. You're just going from a solid to a vapor, but it is still CO2. You haven't changed any chemical bonding. So this is showing a a physical property. My bad. That is a physical property. And then finally, we have the smell of perfume. And that, again, is, I think actually when we talked about properties, we talked specifically about odor or smell. That doesn't change the molecule itself. It's just something that is inherent in the molecule. So that is going to be a physical property. So again, hopefully these are pretty easy and intuitive. You don't necessarily have to know like what the chemical reaction is, but just to know, have we changed the substance or have we not changed the substance? Those are physical and chemical properties. Okay, next slide. So we're still on physical and chemical properties here. I want to do a little bit of a different question. So which of the following properties of carbon monoxide, which is just carbon and oxygen bonded, are physical and which are chemical? So this is kind of a different way to think about it. Instead of identifying something as a physical or chemical property, we have a list for just one compound, one substance, carbon monoxide. Okay, so carbon monoxide is colorless. Color is a physical property. Odorless, we just talked about odor or smell. That is also a physical property. Now, it is toxic. So if it's toxic, then what's going to happen is it is going to change its bonding. And what it does, of course, is it binds with your hemoglobin really strongly. So toxicity is a chemical property. So C is actually going to be a chemical property. D, it is a gas at room temperature. Again, when we're talking about phases, we're really just talking about physical properties, or as we'll see later, physical changes. So the fact that it's a gas at room temperature is a physical property. Okay, so E is burns with a blue flame. All right, so kind of the key word here is burns. That is talking about flammability. That is talking about a chemical reaction. So that is going to be a chemical property of carbon monoxide. And F is, it is slightly less dense than air. And really, it is just slightly less dense. Just like when we talked about the previous problem with the toys and the density is going to be a physical property. That's not something that we need to see when it reacts with something. Okay, so those are a couple of physical and chemical properties of carbon monoxide in particular. Okay, so I have a question from Aaron. What about fusion or fission? That is a great question, Aaron, and that's really going to tie into my next slide quite well. So now that we're comfortable with physical and chemical properties, we can talk about physical and chemical changes. So Aaron, give me just a second. Let's get our definitions in, and then I will talk about fusion or fission, because that's a fantastic question. Okay, so definitions. A physical change. So this is a change that, again, is not going to alter a substance's composition. So you can see how it ties really closely into physical properties. We are not altering the substance when we talk about a physical change. Again, one of the most common physical changes is a phase change. So you can think about, again, melting that ice cube. It looks different, but you haven't actually changed the composition of water. It's still H2O. Okay, so a chemical change. This is a change that is going to alter a substance's composition. So when we talk about something being flammable or something burning, then you're talking about breaking chemical bonds and making new chemical bonds. So what we're doing here with a chemical change is we're taking a substance and we're turning it into a different substance. Again, maybe you're just making a new bond. Maybe you're only breaking a new bond. Maybe you're doing both. You're making and breaking new bonds. As long as you're doing something with the chemical bonding, then you are going to have a chemical change. So Aaron, this now brings me to your great question on fission and fusion, because a lot of times students think that those are chemical changes, right? Because you have changed the substance. You have changed the substance, but you have not altered chemical bonding. You have actually altered the nucleus of the atom. So that Fission and fusion are examples of a nuclear change, not a chemical change. But because it really just applies to those two main situations, most Gen Chem classes will only focus on physical and chemical changes. And then maybe at the end of the semester or the year, depending on how long your class is, you might do nuclear chemistry, where you can investigate those nuclear changes and calculate things like half-lives and all of that kind of stuff. But that's a great question, because it is still a change, but it's a nuclear change, not a chemical change. Okay, great. I didn't see any other questions. Let's keep going. So now that we know we have defined chemical and physical changes, now we get to really kind of the heart of this live stream, and that is the 5 most common signs that a chemical change has occurred. So I like to do these 5. Of course, if you ask Google, you can get 7 signs of chemical changes or 10 signs of chemical changes. But I think a lot of these end up being repeated, especially once you get to the 10. But anyway, so my preference is to just look for these 5 common signs, and they will give you a big hint as to whether a chemical change has occurred. Now, this doesn't always hold true, but it should kind of get your mind thinking about, oh, this is one of these 5 signs has happened. I think this is probably a chemical change. Okay, so let's just run through these, and then we'll talk about some situations if they are physical or chemical changes. Okay, so first is the formation of a gas. Now, this is where, again, some people classify formation of a gas in like a change in smell or a change in odor as 2 different signs, but I tend to put them under one sign. So if you are forming a gas, again, you might notice that you've gone from something that doesn't have an odor at all to something that does have an odor. Okay, that would be a sign of a chemical change. You might have something in solution and you might see bubbles. That could also be a sign that you've got a chemical change. So maybe you've got a chemical reaction going on that is, say, creating hydrogen gas, and those are the bubbles you see. Again, a situation where this is not necessarily true is like when you open a soda or something that's carbonated, you see a lot of bubbles. So you think, oh, is this a chemical change? Well, not always. So what you've got is you've got carbon dioxide that's dissolved in the liquid, and when you release that pressure, that carbon dioxide escapes. Now, there is a small bit of chemical reaction that takes place. The CO2 does form some carbonic acid, but a lot of it is actually just simply dissolved in the liquid, and then it is released. So it is CO2 dissolved in whatever solution you've got, whether you've got a Coke or whatever, and then it is released into the gas. That would be not a sign of a chemical change. That's just a physical change. So again, always take these signs with a little grain of salt, because they may be a sign of chemical change, but not absolutely always. These are not hard and fast rules. Okay, so my second sign is formation of a precipitate. So you see this is actually a great chemistry demonstration. So you take 2 different solutions. It really works well if they're both colored, and you pour one into the other. Instead of having 2 solutions that have a color, you end up with a solution that has a color, but then you end up with a solid at the bottom, and that is the formation of a precipitate. And that is a sign that a chemical change has occurred. So you have these 2 solutions, you mix them together, a reaction happens, and one forms a solid that comes out of solution. This is very often called a biphasic system, because you have 2 phases. You've got a solid phase and a liquid phase. Anyway, I digress. What this is not is, say you've got a glass of sweet tea and you're trying to dissolve a whole bunch of sugar in it. So if you try to dissolve too much sugar, you might say, well, I have a solid at the bottom. But that was not something that was formed in solution. You're just trying to dissolve too much sugar in your sweet tea. So again, be careful with these and make sure you're really thinking about them. But if you're actually forming a precipitate, then you probably have a chemical reaction happening. Okay, sign number 3 is a temperature change. This you most often see like when you have a fire in the winter, any kind of combustion reaction, whether a fire in the fireplace or a candle, or if you have like a butane lighter, if you grill outside, any of that, those combustion reactions are just really common in our everyday life. And of course, they do produce a temperature change. The fire gets hot, the candle gets warm, all of those things. And yes, there is a chemical reaction taking place there. An example of what we call an endothermic reaction, or a reaction that actually gets colder, I'd say one of the most common or well-known ones is photosynthesis is actually an endothermic reaction. So that is a reaction that is going to, if you were holding it, it's going to decrease the temperature. So temperature change can go either way. You can either have something that gets hotter or something that gets colder. Now, this has to be the reaction happening on its own. So if you fill an ice tray with liquid water and you put it in your freezer, you have not made a chemical change when the ice freezes, because the freezer itself is what's pulling the heat out. It's not a reaction in the water. So again, just these are not set in stone. These are not hard and fast. These are to get you thinking on the right track. Okay, number 4 is the production of light. So if you have something that is producing light, probably there is a chemical change. Again, like a candle, you've got a chemical reaction going on there. It produces heat and light. You have things like if you have fireflies or lightning bugs, glowworms, those kind of things, those are actual chemical reactions that are producing light, but they are not producing light with a lot of heat, because obviously that would kill the bug. So production of light is a sign of a chemical change. Okay, and you also have a change in color. Again, you can change the color of something by not having a chemical reaction. So if you've ever baked a rainbow cake or made rainbow cookies, you change the color of the batter by adding a dye. That is a color change, but that is not a chemical reaction. So what I'm talking about is more if you're cooking your dinner and you burn it, then depending on how badly you burn it, if you burn it really badly, you're going to go from whatever color you started with to black. That is a color change. And yes, a chemical reaction has occurred there. So again, these are my 5 main signs that a chemical change has occurred. But always, check yourself, because there are situations where you might see these signs and it is not a chemical change, but they tend to help you get on the right track. Okay, any questions about the 5 signs? Okay, good. All right, let's apply our 5 signs. All right, so we're going to take each of these situations and we are going to say whether the change that has occurred is a physical or a chemical change. Okay, so let's start with A here. A here, we've got iron rusting. This is classic. So you start with iron and then you're actually forming an iron oxide, which kind of gives it away. That is a chemical change. So you have created a new substance. So when iron rusts, that is a chemical change. Okay, so B is the evaporation of acetone, and you may or may not be familiar with acetone. This is nail polish remover. So nail polish remover, when you put it on your skin, it's like rubbing alcohol. Your skin feels cool. It evaporates very easily. But again, this is a phase change. This is from a liquid to a gas, and phase changes are going to be physical changes. So the evaporation of acetone is a physical change. Okay, C is a coal fire. So you're taking a lump of coal and you are burning it. Any kind of combustion is going to be a chemical change. This is going to also produce light and heat, which are 2 of our signs that something has changed. You could even maybe argue that you get some color change in there too, because you start with a black lump of coal, and while it is burning, usually it's going to have some kind of glow as it gets really hot there. So C is definitely a chemical change. Okay, so D is a carpet fading in the sun, and I have had this happen to me. So you get a great carpet or a great rug, and you're in a really sunny room, and you notice that like the square that's in the sun the most starts to fade. That is a color change, right? So you go from really bright colors to kind of faded and dull colors. That is a chemical change. So whatever dye you've got in the carpet, over time, the sunlight breaks it down. It is no longer the same molecule that it was, and that's why the carpet fades. Okay, E is breaking a window, which maybe you have done yourself as a little kid. Of course, the classic example is the baseball through the window. So when you break a window, are you changing the glass in the window? Well, no, you're just changing the shape of the glass. It's no longer a square or rectangle that fits in the pane. It is now little shards everywhere. So if you're just changing the shape of something, so any kind of cutting or grinding or tearing, that is going to be a physical change. Okay, so F is a firework, which is always fun to see. So a firework, we have light that is coming out. We've got a color change, and I think if we could get close enough to it, we would feel a temperature change too. So watching a fireworks show, you are watching chemical changes occur. G, grinding coffee beans, which I love to do in the morning because I'm always looking forward to my cup of coffee. So if you are grinding, then you're just changing the shape of something. So that is going to be a physical change. If you're just changing the shape, that's physical change. And H, one of my favorite summer pastimes, is grilling a burger. So if you are grilling or you are cooking, then you are going to be undergoing a chemical change there. Again, you'll also see a color change. So you start with the raw hamburger, which is kind of reddish, and you end up with a cooked burger, which is kind of grayish, maybe with some black grill lines. So on the thumbnail for this video, if you look, I have a picture of toast being toasted, and the question is this a chemical or a physical change? Well, that is a chemical change. So that is the Maillard reaction, I believe. Let me know in the comments if I got that right. I believe that is the correct reaction, or maybe my moderator can let me know. But that is a chemical change, and you see that color change in that piece of toast, and hopefully you don't get too much color in it because that's disappointing. Okay, so one more little bit. So this is our last question on physical and chemical changes. So this is a situation. So several pieces of graphite from a mechanical pencil are broken into tiny pieces. The pile of graphite is then ignited. And what kind of changes have occurred? Okay, so we have two processes. First, we are broken into tiny pieces, and then we are ignited. So the wording here really, really helps us. Okay, so broken into tiny pieces, that is just changing the shape of something. So that is still graphite. It's just now in a shape that we can't use in our mechanical pencil. That is going to be a physical change. Now then, this little pile of graphite, now, okay, maybe you broke your mechanical pencil lead in school, but you wouldn't do the next part, is ignited. Okay, so if it's ignited, that means it is burning. We're undergoing combustion at that point. So if we're undergoing combustion, we've got some flammability there, then that is going to be a chemical change. So in this situation here, broken into tiny pieces, physical change, ignited, chemical change. Okay, so that is it for our physical and chemical changes. Again, this tends to be something you see at the beginning of your chemistry course. I hope you found this helpful. Again, please let us know what topics you would like to see on the live stream. And I hope you guys have a great rest of your Wednesday. Bye.